Hi, it's B. Cameron Gain with the New Stack. I'm here today with Jon Bock, Vice President of Marketing with Streamlio Cloud, which provides a streaming messaging solution that runs on the cloud. Thanks for joining us today, Jon.
Thank you.
So, in lines with what we were talking about before, could you please explain, why should developers be interested?
Yeah, so one thing that's been the case is that most developers who are writing applications that process data have dealt with data that was coming from batch repositories in the past. And yet now there's an increasing emphasis on having developers to write applications that can handle data as it arrives. Whether those developers are data engineers who are developing code to process data, or whether they're actually developers writing applications that embed data and analytics. And so one of the challenges in the past has been that for a developer to work with data as quickly as it's arriving used to require complicated stream processing engines and complicated functional programming paradigms and different SDKs and APIs and such that were pretty unfamiliar to most developers. And so it became a pretty big barrier for them to develop these applications that could process data as quickly as data arrives. And so what we've actually done here at Streamlio is put together the technology needed to make it easy for developers to have a simple experience for developing applications that can operate on data immediately, but also to make it easier for those developers when those applications and that code are pushed to production. We certainly talk a lot about what it takes for a developer to create code, but a lot of the developer's time is actually spent dealing with how the code that they wrote is operated in production and spending a lot of time with DevOps and with the production ops team, helping them to figure out how to make sure that code runs effectively in production. And so that's one other thing that we really spend a lot of time at Streamlio is really thinking about how do we make an environment where when a developer deploys their code, it's very easy for the developer and the ops team to work together. And in many cases, the ops team can be independently addressing some key challenges that they might see in performance or in throughput as they monitor the application without really needing to put a big burden on the developer. And so that's really what our platform for messaging and streaming is all about, is making that something that is much easier for a developer to be able to work with.
And is this something that might go with version control software, or how would that work? Or would there be any overlap?
Yeah, so this definitely complements what people are using today for everything from their IDEs to their CI/CD tooling and pipelines. Fundamentally, this is about where you actually deploy your code and what the SDK and API is that goes into developing that code. And so in this case, you can use whatever IDE you want. You can put that code that you've created then into a CI/CD pipeline. That pipeline then can interact with our platform to deploy that code and to be able to update that code. And then on the operational side, we provide tools that help both developers and the DevOps people to really kind of understand how that works together. So there's definitely complementary aspects to this that don't require people to change their development tooling and those tool chains.
Great. So could you just walk me through it? How does it work?
Yeah. So what we have up here is we're going to start with the scenario of a developer writing a simple application to do some processing of a stream of data. So in this case, we're writing some functionality to do some processing of a stream of data coming off of Twitter. It's a very simple source to kind of illustrate to you a stream of data that's constantly arriving, constantly changing. And so the developer is going to, be asked to write an application that basically does some simple classification of that. So it's going to look at the data coming through, and it's going to use some simple machine learning to decide whether those tweets that are coming through are positive or negative. And based on that, it's going to create new streams of data. It's going to create a stream of data that's going to have all of the positive tweets about the given keyword that they're looking for. And then it's going to create another stream of data that's going to have all of the negative tweets. So this could be more like a data engineering type developer where they're focusing on creating some additional data streams that are going to then be used by applications. You can imagine all different types of applications that this could feed into. So in the past, if you had wanted to create this type of processing, you probably would have used some complicated stream processing engine. It would have had a complicated SDK. What you can see here is actually a pretty straightforward set of code that allows people to leverage existing libraries. In this case, our code is pulling in some existing NLP libraries that are doing processing of that data, and incorporate that in a very straightforward way. The code itself basically just needs to understand that there are inputs. Fundamentally, those tweets coming through are the inputs in this case. And then there are outputs. In this case, we have an output for that stream of negative tweets about our keyword and an output for the stream of positive tweets about our keyword. And so that is basically all that there is to the SDK and the API. And this code here, which probably many developers have written similar code already, just kind of illustrates it's relatively straightforward to write this code. You won't see anything here that's related to functional programming, maps or flat maps or concepts like that. You won't see anything in here related to the need to understand DAGs or things like that in the environment. What you see here is basically just something that focuses on the logic that the developer is creating. And so you could imagine, there's a parallel here that we really wanted to create that was about the way that people are really kind of adapting serverless and low-code environments. We wanted to bring that into this world of streaming and messaging. And so rather than having to have some complex coding happen, developer focuses on the logic that they want to write, and then they can deploy that to an environment where they don't need to understand the details of the infrastructure to actually make that code operational. In this case, we're showing you a Java example, obviously, but these could be done in things like Python as well. And fundamentally, all that needs to be done to make this usable now is to compile it into a function. So Java has that notion of functions. You can compile that. It doesn't require bringing in a bunch of other libraries, things like that. Python has this notion of functions as well. So fundamentally, what we've done is taken this code, put it into a function. We can then check this into our version control system, for example. That could then kick off a build in the CI/CD pipeline. And that CI/CD pipeline could eventually then deploy this into our messaging environment. What we've really focused on at Streamlio is how do we make that experience seamless for a developer? In this case, as you can see, this is an IDE. We don't provide the IDE because we know that developers already have their preferred IDEs. We make it very easy for people to integrate with this because we can be the destination for the CI/CD pipeline to push that. And that's how some of our customers are already using this capability. So that was kind of talking about a little bit the development side. But as we mentioned before, one of the big challenges for developers is often that they get pulled into dealing with a lot of the production and operation side of things. Certainly the ops team isn't going to know the internals of the code that developers wrote. And so often they actually bring the developers in and have the developers actually spend a lot of time helping them to understand what's happening in the production environment.
And the SREs also play a role.
Absolutely. Yeah. And so those are critical teams, but they also put a pretty big burden on the developers who have to work with them constantly. If, for example, there's a performance issue in the environment, it's very common for the SRE team or the DevOps team to have to go back to the developer and ask the developer to spend some time helping to troubleshoot that and giving them recommendations. But we really wanted to kind of decouple that a little bit more so that the development team didn't get burdened as much by those operational concerns. And so that's what we're going to switch over to you now, and we're going to show the way that this looks for someone who's actually operating the environment and how that can help to facilitate the communication between developers and that SRE or DevOps team. So we're going to switch over now to a UI that is designed primarily for the ops and SRE team to look at, but also is something that developers can look at as well. Because certainly when a developer deploys code, one of their first things they're going to ask is, well, how is it working? Are things working as expected? So this is basically kind of the front end dashboard that you can see as you log in. And one thing that's important here is that in many cases developers have typically been deploying to kind of isolated environments. So you develop your code, you develop it, and then you deploy it to a cluster, and that cluster is limited to a single team, for example, or maybe a single application. But increasingly, especially as we get into microservices and such, the notion that every application or every service is going to have its own cluster for processing, it just doesn't make sense anymore. And so as a result, people are going to be operating in these multi-tenant environments. And so as a developer, the first thing I start to worry about is, well, does that mean that I'm going to be colliding with other developers? Am I going to have namespace conflicts or collisions and things like that? So that's something that we did definitely build into this platform, is this notion of a hierarchy of entities that allow us to isolate different groups and different applications. So we have this hierarchy. You can see it here kind of at the top of our dashboard of tenants, namespaces, topics. That basically is a structure that allows us to separate different groups and different applications and even different specific services and subcomponents. So you can think of, for example, a tenant might be sales or might be marketing or might be business analytics. A namespace might be customer satisfaction or sentiment or things like that. And then a topic is going to be an individual data stream. So for example, in this case, we could click into the topics. And you'll see there's a bunch of different topics here. Just a couple I'll mention. That Twitter One topic that you see there, that's basically that stream of data that's coming in off of Twitter. So that's kind of the input data that we're using for the purposes of this demo. And then as we scroll a little bit further down, we can also see that there's a couple of other topics, and that's related to the output of that function that I just mentioned. So that function that we just showed you earlier is basically creating these two new data streams, one called positive tweets, the other called neutral tweets, that are basically the result of doing that NLP processing on that incoming stream of tweets. And then you see other topics here as well. So these are basically different streams of data that potentially an application developer might want to use. Now, I, as an application developer, I have access only to the ones that I've been given access to. I don't even see the other ones. So there could be a completely different namespace or completely different tenant. And if I haven't been given access to that, I don't see that. So from a developer's point of view, I can operate and think about just being kind of in my sandbox, so to speak, and not have to spend a lot of time worrying about, coordinating with other people to make sure that we don't have namespace collisions or that our identifiers, don't clash or things like that. I basically have my own separated environment. And that also applies when the SRE and ops team is trying to figure out how to allocate resources. In a multi-tenant environment, I as a developer don't want to have to basically put a lot of resource management into my code. I want that to be something that the operations team handles. And so what this actually does is, it allows me to, as a developer, to give the operations team the ability to, see how to manage resources. So the operations team can set quotas, and do other resource management that can operate on these different levels, like these topics, for example, to really control how many resources are used, so that a runaway application doesn't cause all other applications on the system to fall behind or to be starved. That's another key aspect of making it possible to deploy this in a multi-tenant environment without a developer having to understand all those details about what's underneath or even what other applications and groups might be using the system.
Is it possible to maybe it's at the previous slide, but as far as the production pipeline goes, for example, before we get to the operations side, where are we seeing this interface, or how is this showing data, for example, about the Jenkins pipeline or
So the monitoring of the CI/CD pipeline is going to be upstream of the Streamlio platform. So we're not going to show you that directly. That's going to be the tools that you already probably use to monitor your pipelines. Whether it's various Jenkins type dashboards or other tooling type dashboards from the various CI/CD sort of tooling components. We're basically where you're deploying that, and so we're kind of the output. When we get to the end of the build process, where do the artifacts get deposited? That's fundamentally where we are. So that code that you saw earlier, that would have gone into some compile process. And then as the final step of that compile process, it would have generated, a Java function. And then that function, basically through simple scripting integration would be something you could easily have deployed then into this environment. And now it's given over to the ops team to help you to, QA it, to stage it, and then to move it into production.
I'm assuming this is in multi-cloud. We can incorporate multi-cloud environments into this interface as well, or how does that work? For example, you have on-premise, you have a few maybe Lambdas, you have Google Cloud. Is it able to pull all that together in this interface?
Yeah, so this is entirely based on an open source software called Apache Pulsar. And so that software can run on any environment. You can run it in hybrid cloud environments. So you could be running an instance of this, in your local data center. You could be running this, managed by yourself in any of the public clouds. And we also do offer a Streamlio managed version of this, which is what we call Streamlio Cloud. And so it is definitely very common that people are using this to help move data among different environments. I may have, a production application running in a data center, but I also may have data sources that I want to process in the cloud because that's, the first place that I'm able to aggregate those data sources. And so there's definitely, some great capabilities that this allows you to unlock in terms of being able to move data in a way that's, resilient. It guarantees you won't lose any data. There's replication that can be used across different sites from edge to cloud to your data center. And so there's a lot of flexibility and capabilities there that a developer doesn't have to worry about. A developer just needs to think about streams of data and what they're doing to process that data. They don't need to worry about thinking about how does that get replicated because that's something that the operator and the SRE team can handle directly themselves. Let's drill in a little bit. So let's drill into one of these topics. So let's drill into that Twitter. We're going to take a look at just an example of some of the things that are happening here. So I, as a developer, I might be monitoring this a little bit because I want to know when I've deployed my application that nothing's gone wrong. But I'm going to take a look at this and I'm going to see oh, okay, interesting. I see data's flowing through. I can see that. But I do see that, the storage rate is growing over time. And I do see that, maybe there's going to be a need to, expand the parallelism of how this is being processed. Now, I might, as a developer, not go any further at that, or I might not even have to go there because, this is something that the ops team can also see. So my DevOps team and my SRE team, they can look at this and say oh, okay, interesting. I see there's a little, there's a little bit of kind of a growing backlog. I can see, who's consuming that. Maybe I actually need to add a little bit more horsepower to be able to help this to, process a little bit faster. So, what I can do as my SRE team, I can go in and say initially that processing, that was done by a single worker. Well, what if I want to actually now have that done by a significant greater number of workers? I can actually just go in, expand the number of workers in that pool. I don't even have to go to get the developer involved. And so the developer, they just wrote a simple function. They didn't have to understand distributed programming. They didn't have to think about, complex, ways to coordinate across different elements. That's handled by the platform here. And so that allows the DevOps team and the SRE team to say like, okay, I can go ahead and I can increase that parallelism directly. And that actually will help to keep the system stable and make sure that we're processing data as quickly as it's coming in. Because you could imagine, for example, there might be some spike in the incoming data. In the case of Twitter, there could be some spike because there's a trending hashtag that happens to be related to my keyword. And so I see a big spike in data. I don't want to fall way behind in processing that data. And so I can simply increase the parallelism and then never have to bring in the developer. At the same time, the developer can kind of see what's happening as well. And so they can say like, oh, okay, good. It looks like, the team is being able to keep up with the data. I don't have to get involved as a developer. I don't have to do lots of performance troubleshooting because that's kind of something that, the team can now take care of directly themselves. So this is definitely, very different than what you often see in many application environments. Many application environments, the developer has to go in and they have to write detailed code to emit specific metrics. They have to provide, different ways to be able to troubleshoot and trace different things going through the system. In this case, what we've done is we've basically built that into the platform so that the SRE team and the DevOps team can handle most of that self-service. So we've shown you the example of I can increase, the number of different parallel instances of that code that are executing to process that data coming in. There's also cases where we can actually add brokers. So because this is fundamentally a messaging system, one key aspect of it is brokering. So adding brokers is a very simple thing we can do as well. And so we can increase the amount of throughput that system can handle in that aspect. And then the other aspect is the storage of this. There are many cases in stream processing where I actually do want to be able to look at more than just the current event in the stream, but I want to look at older events in the stream as well. And so, the technology that we've built based on Apache Pulsar has the ability to have this effectively infinite stream storage in the cloud because it can leverage things like Amazon S3 or Azure Blob Storage so that I actually have full access to that. So that's another thing that I can, as the SR team, the DevOps team can go ahead and handle scaling of that without the developer having to be involved. The developer, they just know that they have access to even potentially the whole history of the stream of data in one system without needing to know exactly how that data is stored. And the SRE and Ops team, they can go ahead and they can basically scale that up as needed, non-disruptively, for the application. So, if you think about, what a developer would have to do in the past to write this type of application, they typically have to be very conscious of exactly where the data is. Some of the data in traditional environments would be in a stream processing engine. Some of it might be in a data lake. And some of it might just be in a key value store or some other type of database. And their application would actually have to have all this logic to understand which data to ask for from where, and to deal with the fact that sometimes, the data is aged out of some of those systems. And so as a result, the application has to first check, is the data here? Okay, if it's not here, I need to go check this other system. What we've done with this storage capability that's part of Apache Pulsar and offered through, the Streamlio solution is we basically remove the developer's need to think about that. The developer just knows that if I want to get access to any data in that stream, I have that access in one system. And so that is another aspect of what makes this a lot simpler for developers than what they would have had to deal with in a lot of traditional stream processing or message processing type environments.
Are there any plans to maybe add to or expand on the metrics, or is that considered sufficient right now?
Yeah, so on the metric side, there's a core set of metrics that we have that are just built into the platform. So metrics, everything from, how many times is the function processing to how much data is flowing through that function to what's the backlog into that and so on. So those are the standard metrics that are fully available. We actually feed them, and collect them via Prometheus. And because of that, there's a lot of different integrations that people can integrate into their various tools to actually then visualize those metrics. So it's everything from, you could put a Grafana dashboard in front of this if you want to create your own, to you could use one of those, commercial packages out there for metrics viewing and drill down. So, that fundamental framework is there. And then we also allow you to emit custom metrics as well. And so those custom metrics can come in a number of forms. You can, for example, there's a facility to allow you to emit log messages without needing to, write your own logger or bring your own loggers in, and then those can be fed through that system. But there's also custom metrics that can be created and fed through that same framework so that they're available through Prometheus as well to any tool that's connected to Prometheus to be able to scrape those and visualize those and help people to understand them.
Okay, looks good. And any kind of, you mentioned Prometheus, anything, maybe any kind of overlap with Grafana for example, or any other kind of interfaces there?
Yeah, so Prometheus for us it's great because it can help us to collect those metrics, and then those metrics can be surfaced in any number of ways. Like Grafana is certainly one thing. We've worked with a number of customers to give them dashboards using Grafana that actually can be customized, and then use those to view both the standard metrics that are available in the system as well as custom metrics that they might have created for their application. So that's certainly one possibility. We also worked with other tools. We've worked with companies where the SREs, for example, they use Datadog or systems like that. And so that's allowing us to go ahead and integrate with those as well. So that's actually a good point in that this gives you the framework that I, as both an SRE, a DevOps person, or a developer, can tie into other tools. Certainly, like the developers probably don't spend much time in things like Datadog or things like that, but they might want a simple dashboard that can allow them to monitor, like that new code that I deployed. Is that performing well? Are things working well? This is just an example of a Grafana dashboard. So, this is something that, we've created for a number of different customers that basically ties into that metrics collection system to show them just some different statistics. So this is kind of an ops dashboard. But you can imagine, a subset of this obviously could be made available to a developer as well, so that they could actually take a look at some of the things that matter most to them. You can see here, for example, there's function metrics and topic metrics. I, as a developer, I actually might care about those topic metrics because that really shows, how much data is flowing into my processing code, my stream processing code. And, it allows me to look for, anything that might be anomalous there. Like maybe I know that, I pushed new code that was deployed, and I would look, at these charts to see, was there some sort of change in that? Because, that could be indicative that there was a problem in the code that I pushed when I'm doing my QA and testing. So there's definitely a lot of different ways to see the data in this environment that allows the DevOps team, the SR team, and the developer to all have different levels of visibility based on what they need to see.
Great.
Yeah, so stepping back for a second and talking about what's available to the developer and what's handled in this platform. So one of the key things in messaging is delivery guarantees, and so that's something that is definitely something that in many systems a developer has to consider how to write those into their application. But what we've done here is take that notion of delivery guarantees. Many people in messaging are familiar with that notion, and basically have the platform take care of that. So things like exactly once, at most once, at least once delivery. All of those are something that can be set in the platform, so that the developer doesn't have to write extra codes to take care of those. So that's another aspect of something that could have been a burden on the developer that's now taken care of by the platform. Similar examples are, people who've written messaging applications before, they're probably familiar with the concept of, keeping track of offsets or cursors and things like that. The idea being, if I am an application, I need to keep track of what messages I have seen and what messages I've told the messaging system I've seen, to make sure that the messaging system knows whether it needs to redeliver messages, or if I am in the stream, if I get disconnected and reconnect. In the case of Streamlio and of Apache Pulsar here, we actually have that handled on the server side, so that the application developer doesn't need to understand those things. The application developer, just needs to write the code that processes the data, and the system will take care of keeping track of where in the stream that specific application consumer is. So that's another key aspect. That's something that's handled by the system rather than the developer. In terms of getting started with this, typically we're finding a lot of people start with the cloud version. And so we actually have a managed service for that, so that people don't need to even worry about setting up software. They can basically just let us know, and we can set them up with an account to go ahead and start using this in the cloud. But certainly if they wanted to deploy, we're very friendly to Kubernetes type environments. And so it's an application that fits really well into those type of environments. So people who are running in the cloud on Kubernetes or on-prem in Kubernetes, that's a very common way for people to deploy. But certainly, we also do provide packages and things like Ansible scripts and such for people who might be working on just, bare metal virtual instances in the cloud, or even, installing it on premise. And so there's a lot of different ways that this software can get installed. For the developer, most of that they won't have to worry about. That'll be taken care of by the ops or the production infrastructure team. They just basically need to work with their DevOps team to make sure that the integration happens with the CI/CD and the build pipelines, so that they know how to be able to make sure that the code that they check in gets deployed to that environment. So from a developer's point of view, there's not a lot that they have to worry about or learn new here. And the fact that it's available in cloud editions makes it even easier for a company to try it out and get started.
Is it possible to provide maybe any pricing info?
Yeah, so fundamentally the pricing, there's a couple different models. If you're using it in the cloud version, there's pre-packaged configurations. You can take a look at those on our website that basically, are designed for certain throughput levels. And so, you choose which is appropriate for you. And then on the Streamlio side, we manage ensuring that, we're delivering the right resources to make those throughput levels possible. We don't have the pricing numbers. Obviously, we work with people directly on. Then, if you want to use this, in an environment where you're managing it yourself in an on-premise type environment, we actually do also provide licensing that's based on the amount of resources, in the underlying messaging cluster that's running the system. So, because it is kind of messaging and data processing infrastructure, that's the approach that we take in the on-premise environment. We do have a trial to get easy to get started. We don't charge you for that trial. We just deploy it, in your Amazon account, similar to what you might have seen with like a Databricks or things like that. So you have an easy way to get started with that as well.
Okay, well, Jon, that was great. I think this can definitely be helpful for developers. And thanks very much for taking us through this.
Thank you. Appreciate it.